Hello everyone, this video will introduce a developing field called BCI, also known as Brain-Computer Interface. Our engineering project is designing an electroencephalogram brain-computer interface, which is a device that allows you to control an object such as a mechanical arm using only your mind. So what does BCI do? BCI consists of brain activity that controls movements, communication, or any other interaction with the environment through an application or device. BCI is composed of the following parts. The first part is a device that measures brain activity. This is done by electroencephalogram, or EEG. The second part is a computer that processes brain activity. The final part is an application to control. Recall that the first part of BCI is done by electroencephalogram, also known as EEG. So what's EEG? EEG is a technique consisting of detecting the transmission of electrical impulses in the nervous system in the form of electrical waves using electrodes attached to the head, either directly or through a head cap. EEG is an inexpensive and non-invasive method. It can detect brain waves of different frequencies. Brain waves can be classified into 5 categories, corresponding to different brain states. We have gamma waves for concentration state, beta waves for active mind, alpha waves for restful state, theta waves for drowsiness, and delta waves for sleep. Knowing what EEG is, let's get back to BCI and see how BCI works with EEG. The overall process has 4 steps. Start with signal acquisition. It requires EEG to acquire signals from brainwaves. The signals will be digitized and transmitted to the computer. Feature extractions isolates the digital signals that correlate with the user's intentions. Feature translations uses translation algorithms to convert the extracted signals to concrete commands for the controlled device. Finally, device output. The external device takes the algorithm's output to perform a specific task.
How could BCI improve people's lives? As an access technology, BCI is researched on the following fields. For people with disabilities, for applications like communication, locomotion, prosthetic control, and neurorehabilitation after brain injury or stroke. BCI can also be used for gaming, for neurofeedback, and meditation, for assessing fatigue and stress, and much more. What are the challenges of EEG BCI development? BCI is a relatively new field, so it is currently under research. Most of the BCI practices are only done in laboratories. The general public has no experience with it. In addition, design for the general public is also a challenge. Comfort and efficiency of the hardware for signal acquisition, as well as reliability and value for different users, should be taken into consideration. BCI research involves professionals from various fields, including electrical engineers, software engineers, biomedical engineers, neuroscientists, and etc. Neurologists and other health professionals also need to participate in the operation and application phase of BCI. We'll be introducing some important professionals in the project of EEG BCI. Electrical engineers make sure what components of the device can be used to perceive the electrical signals clearly. Electrical engineers are also responsible for designing dry electrodes attached to a simple wireless headgear, which enables a comfortable experience for the patient during longer use, while also maintaining a good conductivity of the signal to the processing system. Also, electrical engineers can optimize filters and materials to reduce noise and amplify signals. Software engineer can develop softwares that connects the readings of the device and shows the results in an organized way on the computer. Furthermore, their tasks can also include noise filtering, as it is also becoming possible in softwares. They can use AI to train the computer to map these patterns, and they also account for data acquisition, signal processing, and decoding.
Neurologists and other health professionals are responsible to learn how to use the device, monitor patients while using the device, and discuss health outcome or safety issues, as well as applying the device in the real world. However, despite high potential and thousands of patients who might benefit, BCI awareness among clinicians caring for disabled people is poor.